All right, great. Thank you very much for the brief introduction, Basant. Um, I've shared my screen now. Hopefully, all of you can see it, right?
Yes, it's quite visible. You can go ahead.
Uh, awesome. Thank you very much. Um, let's just start with my introduction, and then we'll go ahead with the topics that we have for today. In order to reduce any kind of audio interruptions, I suggest that we keep ourselves on mute. Um, please, still hear some background noise. Okay, great. So now it's calm. However, that doesn't mean that we stay calm throughout the session. If you have any questions, please feel free to use the features that we have in this Zoho meeting. You got the hand raise feature, you got the chat options, and at the end of the lesson or end of this 2 hours, if you got certain time, I can unmute you and then we can have a small discussion on these topics as well. But to start with, I am Anand, and I've been in IT for about 16 years now, working on different platforms. It could be Windows platforms, non-Windows, mostly on Microsoft platforms these days. But yeah, last 5 years has been quite a ride on different platforms, specifically on cloud and information security. So I'm mostly working with customers on designing and architecting solutions on Microsoft Azure, and not just that, but other cloud areas as well, like AWS and Google Cloud. I love automation and any service that helps in automation and reducing kind of manual efforts. Well, I'm a big fan of such tools and such services. That may include Python scripting or with PowerShell, and the services that are there in today's world, including Azure Functions, Azure Logic Apps, container services, and Kubernetes. And you're going to hear about these a lot in the next upcoming 2 hours. All right. So that being said, what are we going to talk about today? So this is the today's agenda. All right. So what is serverless computing? What comprises of serverless computing in Azure? So we'll be talking about Azure Web Apps, Function Apps, Logic Apps, what containers are, how do you build containers using Docker? What are the various terminologies used in Docker and container services? How do you host a web application, orchestrate it with Kubernetes, and understand the Kubernetes architecture? Keep in mind that it's not just a theoretical class, but it's also hands on. We'll do as much as hands on as possible considering the amount of time that we have. Now, as far as containers and Kubernetes is concerned, we'll be doing certain hands-on on that, at least giving you a level 200 of Kubernetes and containers. But for the remainder of the serverless computing features in Azure, like web apps, function apps, logic apps, we're going to talk about them in theory because there isn't much time left for for us to maybe do the labs in each and every section. Okay, so that's where we have limited this timelines here to have labs on certain areas, to talk about theory in certain areas. But then this is not the only webinar that Whizlabs conducts. There will be new webinars coming up in future where we will have lots of demonstration of other features as well. But we got to respect time as well, so we'll make sure that we do the labs for what we designed and what we thought about in this set of lectures that we got. All right, so here's a small poll that I have. So before we dive into various items like web apps, functions, logic apps, and containers, I would like to hear from you about what serverless computing is. So there's a poll you should be able to see maybe somewhere on the meeting pane about the poll. So are you able to see the poll for this particular question? How well do you know serverless computing? So you'll have three answers there, like is it in production? No, it's new. Or have you tried, played around certain documentations? Yeah. All right, I'm able to see the results here. Okay. I'll just give another 10 seconds to this as the numbers are still tickling here. That's pretty good. I still see the numbers moving around, but I got a gist of it. I see that there are quite a lot of people who are new to it. So we got 60%. Let me see if I can put the poll on the screen so you can see it as well. Mm, where is it? Okay, so there you go. Can you see this? So we got 60% totally new, 10% are using it in production. Great to hear. And 28, about 30% have played around various serverless options we have in Azure, maybe AWS, maybe Google Cloud, but that's fair. That's okay. Great. So that's that. Awesome. So this was just to know the audience, just to understand whom I am talking to, right? So at this point, I'm really excited to talk about various serverless options we have in Azure. There's a lot to cover in terms of these services. We could do the demonstrations in every service and talk about various use cases where these services can be utilized. However, as we all know that time is a limiting constraint, and we got 2 hours to cover our agenda, which is a lot. So we'll speak about certain services just theoretically, and others we'll do hands-on. For example, you look at Azure Web Apps, Azure Functions, and Azure Logic Apps, right? These are something that we'll talk about theoretically. And the other things like containers, Dockers, and Kubernetes would be hands-on labs. As I informed earlier, Whizlabs constantly promotes technical education through various channels. It could be blogs, articles, training courses, or webinars like these. So don't be disappointed now, as we'll find an opportunity yet again to pick up these new topics in future that may be including hands-on on Azure Web Apps, functions, and Logic Apps. But this time, we'll start with a theoretical concept and understand them. That being said, and without wasting much time, let's cruise into the topic for today, which is serverless computing. The first thing to know about serverless computing is the term serverless itself is a misnomer, is a pretty bad name, I would say, to call it. Because without a server, how can you actually run an application or execute your code, right? So I feel personally that it hasn't been named appropriately. There should be some kind of a server. But looking at it from an end user perspective, end user or an administration perspective, I'm just saying that I really don't need to provision a server, right? So the name serverless instead just highlights the fact that the end users do not need to manage a server to run their code anymore. So technically, in the public infrastructure computing, you got infrastructure as a service, isn't it? That's where you and I and various administrators like us will end up building virtual machines in the cloud. That could be Amazon or Microsoft or wherever. But the serverless computing takes up that idea further and says that, hey, you're going to execute the code that developers write using only the precise amount of computing resources needed to complete the task. When I say precise amount of computing resources, it means that I do not have to provision the resources ahead of time. I just have to write my code focus on writing my code in a well developed fashion, following all the SDLC life cycles and all good things in the software development world, and then just throw it to your cloud provider. The cloud provider then takes care of your provisioning of the resources behind the scenes and gives just that, again using the same term, precise, just as much as it needs to complete the task. Nothing more, nothing less. And you know what happens behind the scenes? You pay just for what you have consumed. Isn't it great? So let's say there is an event. When I say event, it could be an event that is triggered using maybe a monitoring system. That your CPU goes high, like 90% or 95%, because there's a sale going on in Amazon or maybe Flipkart or something, right? Or any other e-commerce website. There's a sale going on, and the um, web servers behind the scenes are so busy handling the traffic, and the CPU spikes up to 90% or something. And the end users will really not be happy at that time because the web server is not able to cater to the needs of the end users, right? So what you gonna do? Well, as an administrator, well, you could have created some kind of an elasticity within that cluster of web servers. But what you could also have done is created a trigger, created an event. Said, okay, if the CPU goes above 90%, take certain actions, right? Maybe call off the sale. Well, you don't want to call off the sale because it's business at the end of the day. So you may be ending up spinning new servers. What is happening behind the scenes here? Elasticity is the buzzword these days, right? And that's the one of the selling points, a unique selling point. It's called as a USP for the cloud. So when such a predefined event occurs, it triggers certain code in the background. That serverless platform where the code is hosted is executing the code, is executing the task. The end user need not tell the serverless function how much of compute power it should use. It will pick up the compute power depending on the amount of time it has to run, amount of CPU and memory it requires, and various other factors included in that. Customers will pay only a fraction of the penny every time a function is executed. So you can call serverless computing as function as a service. If you don't like the name serverless computing because you're just saying that, hey, there are certain servers running in the background, so I'm not going to call it serverless computing. Okay, that's a fair argument. Absolutely fair. So don't call it serverless computing, call it maybe function as a service, or call it event driven function because um, there are certain actions and tasks that are taken based on an event trigger. So you call it as event trigger function. And if you don't like to use the word function, because it can be just anything, right? It can be a function, it could be a web app, it could be logic apps. Well, you don't want to generalize it, then call it event driven computing. That's a better name then. It doesn't matter what name you're using here, because behind the scenes, you will have a server. And for you, for me, for the server admins, and for various organizations that use cloud, they will just have to focus on writing the code and then sending it to maybe web app, maybe functions, maybe logic apps, and let that run for you. So serverless computing, function as a service, event driven functions, or event driven computing, I would call all of them as synonyms. They're all synonyms coming under the same category, serverless computing. So serverless computing is a architecture where the code execution is fully managed by your cloud provider. Okay, so you are not relying on any traditional methods of developing applications. What is a traditional method? We'll talk about that in the next slide, but whatever is the method that you're using on premise, okay? So instead of relying on them, you are using a modern method of building the application. It means that the developers do not have to worry about several aspects of the servers, like managing the servers, provisioning, maintaining servers when deploying the code, right? Earlier, the developer would have to define how much storage and database capacity is required. What do you need for pre-deployment of a function? So naturally, there are servers involved, but in serverless computing, their provisioning, the server's provisioning and maintenance is entirely taken care by your provider. The provider will charge you how much for that? Well, they will charge you a fraction of just the compute time that is used during the execution, and there is nothing called a flat monthly fee for maintaining a physical or virtual server. So, with that, you will be able to optimally utilize the resources, optimally utilize your money as well, right? This is the key, very important for businesses. So that's the crux of serverless computing, right? That's what serverless computing means. If you are into cloud computing for some time, or if you have been there for quite some time, then you might have seen this picture, almost seen this picture, maybe. Okay. um, so there's infrastructure as a service, platform as a service, and software as a service. So if you are in the cloud area, can you see the slides? I hope you're able to see this um, slide. I think I've shared it, but are you able to see it as well? Manish? Basant? Are the slides visible to you? Okay. Right. So Manish, to answer your question about please show the slides, the commentary is very boring. I say it's a theoretical aspect which is very important for anybody. So there's a mixed set of audience who have been there, seen that, and done that. There's another set of audience, according to the poll, who have not been into the serverless area. So it's important to include that commentary, which is probably boring for you. Okay. So theory is as much important as practical. There will be demonstrations at the end of the lessons. So I really, really appreciate your patience on this one. Thank you. So the cloud models, you might have seen this cloud models picture several times if you have been in the cloud, like infrastructure as a service, platform as a service, and software as a service, right? Um, the serverless computing falls somewhere in the middle of platform as a service and software as a service. Okay, so when we think about serverless, I was going to certain forums there and also discussing with some of my colleagues there. And then there was a question that prompted us to discuss for another 30 minutes, maybe. Where is this serverless computing falling under? Is it under platform as a service? Is it under infrastructure as a service or software as a service? Well, because we are not creating virtual machines in Azure or in AWS, it is not infrastructure as a service, okay? And it is not software as a service as well. Why? Well, because it is um, managed by us, right? Software as services like Gmail, like Office 365, like Facebook. Well, these are example of software as a service. So this guy falls under platform as a service, where you will be handling your code, which is the application, and you will be also maintaining the data integrity, data confidentiality, data availability, in short called as a CIA triad, right? CIA triad. So the confidentiality, integrity, and availability of your data is managed by you, me. the admins or the developers. So hence it falls under platform as a service. Another important thing to note. But other things like it could be managing the operating system. Is your cloud provider using Hyper-V, VMware? Well, we really don't care about that in platform as a service section. Are they using SAN, NAS, or DAS? Really doesn't matter. Are they using straight cables, cross cables, or fiber optics? We don't care. Why? Because it is platform as a service, and we just focus on the top two layers, which is application and data. Okay, so I hope that's clear. I suggest that you keep yourself on mute because there's some background noise. Um, thank you. So, Azure Web Apps. This is one of the first services that Azure launched as platform as a service. There was when I started working with Azure back in 2012, as far as I can recall, the first service was infrastructure as a service. Then there was Azure Storage as well, and they also came up with Azure Web Apps. It was called as an app service at that time, renamed to Web Apps now. In this set of slides, initially we said that we're going to talk about web apps. We will refer to logic apps and function apps as well. So we are starting with Azure Web Apps now. So what is a web app? Something that helps you build web application, right? So traditionally, you always build web applications maybe with GoDaddy or maybe HostGator, BigRock. There are so many of these third-party providers today and even before. And we used to take the help of developers and write our HTML, CSS code and all, and put them in those servers and make them available to our end users. But now the whole paradigm of hosting the web application has changed. Okay, um, how has it changed? Well, today we are looking to build modern applications. We don't want to make monolithic applications. We want to make microservices, right? Microservices with the help of various serverless components we have in Azure. So if you look at this architectural diagram, you are splitting up your web application into various components. So your static content, it could be your JPEGs, pictures, HTML, videos, it's all going into the storage, the blob storage. Whereas the front end, which is let's say the HTML, CSS, Java, such kind of processing is all going and storing inside the app service plan, which is like a compute requirement for your app service, which is then accessible via the internet. If you need any databases, all they are there on the right hand side. There's an Azure SQL database which can be replaced, or you can add your Redis cache along with SQL database, or maybe NoSQL, Document DB or Cosmos DB, for example. Authentication is done by Azure Active Directory, and DNS resolution is done by Azure DNS. Well, you can clearly see that there is a lot of integration aspects here. A seamless integration, which is what the developer wants. The developer wants to spend more time on writing the code rather than doing these integration aspects. Azure has done, or Microsoft has done all the backend work for you. So these different kind of service offerings seamlessly integrate without any problems, without any errors with other third-party services. Here, I've included only minimal set of services, but you can integrate all of these services with, let's say, Azure Monitor, with Azure Functions, Logic Apps as well. So what is Azure Web App? Azure Web App is a hosting provider. I can say used as a hosting provisioning place, right? So certain programming platforms or certain coding platforms. It could be ASP.NET. Maybe another developer is comfortable with Java, Ruby, maybe Node.js, PHP, Python. Developer can write code in any language using any framework. It could be PowerShell as well. Azure App Service is compatible with all the platforms that I just listed. It's ASP.NET, Java, Ruby, Node.js, PHP, and Python, and PowerShell. DevOps is becoming another buzzword here. A continuous integration and continuous deployment concept with Azure DevOps is very important. How do you integrate with third-party service, not just Azure services? The examples could be GitHub, Bitbucket. How do you integrate with Docker Hub, container registry? So Azure App Services promotes integration with several third-party services like the ones that I just listed. This is globally available. So Azure guarantees that the app service will be available 99.99% of times. What else do you want as far as availability is concerned? Developers love to write their code in Visual Studio. Well, you got Visual Studio integration. So Microsoft has done their best efforts to integrate with third-party solutions and the solutions and services that Microsoft provides. And the tools, for example, Visual Studio, it could be mobile applications as well. And of course, different kinds of languages and frameworks it supports. So Azure App Service is used whenever you want to write an HTTP based web application. It could be REST APIs or it could be a backend connecting to your mobile. Okay. All right. Now, the second section here under the serverless computing is Azure Function Apps. All right. So I'm just looking at the chat to see if you have any questions. I don't see any of those questions here. But like I said, if you have any questions, please feel free to put them in the chat. I'm constantly monitoring the chat and I will address them as and when there's an opportunity. Thank you. Azure Functions. Now, we spoke about this in brief earlier, but we did mention that you can just take your code and put them in Azure. And that's Azure Functions. You can write small pieces of code without worrying about the underlying Azure infrastructure. What kind of infrastructure will my code need? Well, we really don't care. We just have to take our code and put them in Azure. So Azure spins up the entire cloud infrastructure for you, ensures that it is secure, ensures that it is updated as well. And if the function apps is running several hundred times in a day, then it is made scalable as well. A function is a code that is triggered by a specific event. An example that I gave earlier was about the monitoring thing, right? When the CPU goes above 90%, it needs to maybe send an email to somebody. So that was a kind of trigger that I was referring to. These triggers could be as a result of changes in data. For example, I'll go back to the previous picture here. You got storage blob, right? So I'll say whenever my customer uploads a picture above 10 GB in size, maybe he's doing a high definition photography with drone cameras or using HoloLens, right? Using HoloLens to take pictures, maybe whatever. So, and they then get updated to blob storage. Okay. So, in that case, I would like to get alerted because the size of the picture is just too big. Maybe somebody's capturing a 4K definition video, right? So think about organizations like Netflix and Disney, and they are using cloud providers these days, specifically multiple cloud providers, Amazon and Azure specifically. So when somebody's uploading one video file of, let's say, 64 gigabytes, I should get alerted. So it's an event. Uploading a file is an event, and you would like to get alerted and then maybe take an action, respond to that activity as well, right? So these are certain things that can be done with function apps. Function apps is part of the serverless code, serverless application. And again, just like web apps, function apps also supports different kinds of programming platforms like C Sharp, Java, JavaScript, Python, and PowerShell. And this keeps on increasing. When I first saw function apps, it was supporting just PowerShell and JavaScripts, but they have increased their portfolio to C Sharp, JavaScript, and Python now. Just like any other service, function app is also pay as you go model. You can bring your own dependencies. There's a lot of integrated security into function apps because it can integrate with Azure Active Directory. So you can authenticate yourself with Facebook, Google, Twitter, Microsoft accounts, anything you like, right? So there's a lot of integration capabilities available inside function apps. There's a lot of open source information available for Microsoft function apps in the GitHub. So if you'd like to run around certain functions and take a look at them, there's a lot of information in the GitHub and it's all open source for you. The next one in this category is Azure Logic Apps. So what is Logic Apps? Now, you know that businesses are today moving towards digitization, right? There's Logic Apps that help you connect with legacy, modern, and cutting edge systems. And you would like to easily and quickly provide connectivity to such interfaces. Logic Apps has a lot of predefined, pre-built in APIs and connectors. With function apps, what you're doing is you're writing that code manually. The major difference here is that function apps, you write the code manually. But with Logic Apps, you have predefined connectors. An example that I was giving earlier was the size of the picture, which goes about 10 GB, and somebody uploads that to a blob storage, let's say, or somebody uploads um, a file to your Google Drive or SkyDrive, OneDrive. You would like to get alerted. In that case, earlier you have to write a lot of code. So Microsoft Azure has not only made their platform easy for developers, but also for administrators who cannot write code with C Sharp. Administrators are not well equipped with that knowledge of writing code in C Sharp or JavaScript. That's not their key competency. So with Logic Apps, what we can do is use these predefined connectors, and there's a lot of APIs running behind the scenes. So I can just drag and drop those components and make a workflow like you see it in the in the picture there, in the screenshot there. However, you still have the options to write and modify and do your own coding if you need, and integrate with Azure functions if you want. But then there's a lot of inbuilt APIs that are there that will let you connect to different kinds of Microsoft managed connectors, right? So in this example here, so what I'm saying is, if you look at the screenshot closely and look at the workflow there, what's happening? So when a record is updated, it could be in the database, it could be NoSQL. Every time there's a new customer, a record is updated, right? Then what's you gonna do? Well, we will transform an XML file, we'll update an XML file, register it inside another database called as data mart. It's just a name that we have given. And if the record requires an action, if it is true, then you are uploading it to a Slack post message. Now, Slack is a third party tool, so you see how easily it is able to integrate with third party services as well. And finally, send an email notification, and it's sending and integrating with Office 365. So, this is a kind of workflow you have made. So, when a database gets updated, it is sending an email notification, and in parallel, it is sending a post message inside Slack as well, right? So, based on an activity, you are able to take certain actions. Just like function apps, Logic App also does the same thing. But with Logic Apps, you are able to create your own workflow with these predefined templates and APIs that are inbuilt inside Logic Apps. Going back and switching to the poll section plus also the chat section to understand if you have any questions. Plus, I will also get to know about your competency on container services. Okay. So there's a poll. What's your competence level on container services? Is beginner, intermediate, is advanced, not familiar. Okay, I'll just give it 10 more seconds for it to finish and let the participants finish their poll. Okay, great. So we got the poll results here. We got 53% beginners, 23% intermediate, 3% advanced, and 19% not familiar. Okay, so you should be able to see the results yourself as I have unhidden the results from my screen. It should be there. All right, let's start with Azure Container Services. What was the traditional method or the traditional mode of hosting a web application? Before the advent of virtualization, we had physical servers, and those physical servers were hosted somewhere. It could be in the data center or it could be with a colo provider, a co-location provider, and you host your web application there. We then moved to um, the concept of virtualization. So back in 2003, 2005, the concept of virtualization started. VMware initiated that, and then Microsoft called it Hyper-V and Citrix Zen Server and several other virtualization platforms like maybe proprietary and non-proprietary open source ones came up, right? So that's where we created virtual machines. Every virtual machine had its own guest operating system. The guest operating system could be Windows or Linux operating system, right? So I'm referring to the picture here that you see in the screenshot. The picture and the picture on the left hand side has virtual machines, the infrastructure layer, the host operating system layer, and the hypervisor. And then you install the guest operating system. That's where I was. So you will install, let's say, Windows or Linux. And let's say your application is based on IIS, let's say Windows IIS, right? So you have to install IIS service on the Windows 2008 operating system, maybe. And if it's a .NET based application, you have to install the .NET libraries, right? There's a lot of work that you're doing behind the scenes, right? Just to host that web application. And there are a lot of dependencies. So there's your application, the binaries and libraries are your dependencies, and then it is the guest operating system, which is a must, right? That's where the shell interacts with the kernel and vice versa. Great. Now, this application one is destined to live in that green box forever, and app two in the yellow box, and app three in the yellow, and the app three in the pink box. So they stay there. So let's say I have an app four. I want to now build a new application, app four, and it's a very small application. I decide to put that on the same server where app one is. Okay, no problem so far. So app one has dependencies. Let's say it needs .NET 2.5 or 3.5 or something. And then app 4 is the latest one. It needs .NET 4.6 or something, right? So first I have to install the binaries. So I start installing the binaries there. Okay. And as soon as I start installing the binaries, it's gonna probably make conflict with the older set of binaries that are there already. And then when I put app 4 on the app 1 server, both of them may fail to coexist. So dependencies conflict and application conflict may rise to Mm, the administrator thinking that, okay, the whole system is corrupted, so I may need another server. So he ends up spinning up a new virtual machine in the end. An application needs binaries, dependencies, it needs an entire software package, it needs an environment for it to run appropriately. An application is a piece of code that needs its own runtime, its own set of system variables, environment variables, and other essential settings. If there isn't a conflict or a mismatch, it may not work appropriately. And hence, there is a need to isolate these applications, give them separate environments, host them separately. And that's what we were doing as well in that era of virtualization by creating different kinds of virtual machines for every application. They were isolated earlier as well. Even today in the container world, they are isolated as well. But the difference is that we do not have to create multiple virtual machines for multiple applications. So you're not creating 10 virtual machines for 10 applications. Instead, the 10 applications can be hosted inside the same virtual machine using containers. The container is creating, now let's look at the right hand side picture. The container is creating a isolated environment, right? Just for that application one. Here, there is no dependency on the guest operating system. It is its own isolated environment which has its own software package and everything that is required for an application 1, 2, and 3 to run respectively. Application 1 has its own code, its own runtime, its own application variables, system variables, the default settings, binaries, and libraries that it requires inside the small container. This container is hosted inside the virtual machine. You can have multiple containers hosted inside the same virtual machine. So that is a major difference between hosting on virtual machines versus hosting on containers. Okay, so let's see if there are any questions there. Okay, so I've got few questions here, right from logic apps to containers. Pick up the containers one first. Is containers runtime is hosted on containers or virtual machines? The container runtime is hosted inside containers. Virtual machines are primarily the source of computing, source of storage, etc. But its runtime and its variables are inside the container. Another interesting question: how many apps can be hosted inside the container? It is recommended that you host one app per container for availability purposes and for good performance purposes. When you create a container, you are actually pulling it from an image. Inside the image, you can host anything. Yeah, you can host the entire set of environment variables, the application. It can all be packaged together. But you will essentially have, at least what I have seen in production environments, is that you will host one application per container, easy for documentation purposes, for troubleshooting purposes as well. So if there is a problem with one application and you would like to bring the container down, then you're not touching the other application at all here, right? So technically, you can host multiple applications inside the container, but you do not do that. It's one is to one. Container is a software. No, Docker is a software. You create containers with the help of an orchestration technology like Docker. Container is a technology. So you'll say you're just creating a container. Like, for example, when you say virtualization, is virtualization a software? No, right? Virtualization is a technology. Similarly, containerization is a technology. You create virtual machines with Hyper-V, you create virtual machines with VMware. Similarly, you create containers with Docker. You create containers with manage containers with Kubernetes. You create containers with Mesos or DCOS Swarm, etc. So there are different softwares that will help you build containers. So containers is or containerization is not a software. It's a technology that helps you build containers with the help of tools like Docker and Kubernetes. Right, Sujit? Does that help you answer both of your questions? Thank you. Okay, so I've got a few questions on the top. Can you help explain logic apps in more detail? And the second one is, how are logic apps helpful in terms of managing events? Or which one is better, function? It's a pretty interesting questions from Sumit and Alvina. I would, with your permission, I'll park them for later discussion because I think I somehow missed these questions, or maybe they popped up later. But I will address them towards the end of the lesson with your permission. I hope that's okay. Okay, so how many containers we have on host OS? Thank you, Sumit. Thank you, Alvina. So there's a question from Manikanta. How many containers we have on a host OS? Uh, there is no limit. There is no limit to as many to how many containers you can have in one host OS. You can have as many containers as you can. It all depends on the computing power. How many can it take is a question. It can take depending on how many um, CPUs it has, how much of memory it has. So if you got a massive rack sitting in your data center, it can maybe host thousands of containers. But let's say you've got a very small machine, it's not advised to have several containers on that. Okay, so next question is from Krishna. The question is, what if the same application needs to be deployed into multiple virtual machines? Does it need separate containers? Yes, it will need separate containers. Hosting a container is a 1:1 ratio. One machine, um, one application, one container, right? And if you'd like to have multiple containers for the same application for availability purposes, in fact, that is a way to go. You do that as well. And this is managed by an orchestration service, Krishna, to answer your question better. Um, if you'd like to host the same application on other virtual machines, you would do it with an orchestration service like Kubernetes that helps you do that. What is the storage capacity of each container? Um, one thing to note is that um, inside a container, in production environments at least, yeah, you do not keep the images or videos. You do not use it for storage purposes. You will use a container to just run the application itself, the code, okay, and its runtime and variables. That's all. So where are my static files like pictures, videos? Well, they are in a separate storage system like Blob. So let's say you're keeping all your pictures and images, static content inside the Blob storage, and the web application will be running inside the container. So the size of the container need not be big. The size of the container also depends on how big the code is. Okay, it can just expand. It can just expand up to the size of your virtual machine's hard disk. So it's like, let's say you have a folder on your computer. What is the size of your folder? How much of data can you put inside the folder? Well, as much your storage can accept. So if your storage is like 256 gigs of storage drive, your folder can accept just as that much, isn't it? Nothing more, nothing less. So what is the storage capacity of the container? Well, as much as the virtual machine storage can accept. However, keep in mind that you do not keep all the data inside the container itself. But things like pictures and videos, these things will be stored outside the container in a separate storage drive. Does that address your question, Amol? Is that okay? Okay, thank you, Amol. So now the question, Manikanta, when app runs on multiple containers, how to get application logs from different containers? What are the industry best practices in this scenario? Manikanta, this is a very interesting question. Application logs are so critical, we cannot ignore them, specifically when you want to troubleshoot them. One point that I want to say here, based on this question, is that um, containers are ephemeral. When I say ephemeral, it means that they live for a very short amount of time. It will be running only when the application is running. When the application is not running, it will kill itself and give the resources back to the resource where it is running. Let's say it is running on a virtual machine, then it will give the memory and CPU back to the virtual machine, right? So containers live and die. It is living for a very short amount of time. It is also said that when you go to google.com, okay, when you just go to google.com and put some kind of a search in the search bar, right? Maybe you're searching for, hey, how do you live a healthy life or something, right? Um, or things to learn every day. So you search something in the search bar, okay? It is said that Google in the backend spins up at least 3 to 4 containers in the backend, okay? And then gets the information for you. And now that the search is over, those containers need not be running up and running all the time. So they are killed. They just kill themselves because they don't need to be running because the search is over, the results are over. But if Google want to maintain a history of your search results and what you have been searching for, and you want to know what you have been searching for over a period of time, then you need to maintain the logs somewhere. So if the application hosting the container, sorry, container hosting the application is killed or terminated, the logs are also killed automatically. That is so bad for troubleshooting, so bad for forensics purposes or investigation purposes, right? That's where when you are creating the container, you not only keep the application, not only keep its binaries, but also put a small monitoring agent along with it. If there are security professionals in our group today, you will also understand the importance of uh, a scanning agent, maybe antivirus agent sitting on it, a small lightweight antivirus agent, small scanning agent that is sitting there, maybe a monitoring agent as well, like Nagio sitting there. So when you're packaging that container, your application is there, your runtime variables is there. Along with that, you'll also package these little tools inside it. So when the application is running, it captures those logs, maybe Splunk, okay? You got that universal forwarder. It's called as a universal forwarder agent that's sitting inside the container, captures all the log, and right few moments before the container is about to kill itself, it captures all the logs and pumps into, let's say, a log aggregator service called as Splunk, or in Microsoft world, there's something called as an Azure Sentinel. It pumps in there. So we need the logs. We will keep it. To answer your question, Manikanta, does that address your question? Yes, container contains as the code. Thank you, Manikanta. So the containers suggestible for chatty applications. Yeah, you can host containers for chatty applications as well. Because I also know within the production environment that I have dealt with and seen, there are machine learning algorithms running inside the containers, HoloLens being used to maybe run back and forth images between the containers, process them to identify what it is. Is the picture, the person inside the picture, sad, happy, smiling, whatever, capture these variables, then pump into the storage, and there's a lot of chattiness happening. Yeah, I agree, Sujit. Containers are there for chatty applications as well. Okay, another question from Vishwanath. Uh, Google.com gets killed, but we always find our search history in the devices. Yeah, that's what I said. So logs are preserved. Logs are preserved. Your search, the containers were used only for computing purposes, but not for storing the logs. Logs are preserved. The search is not getting killed. When you search for something, it needs some kind of a computing behind the scenes. The containers are used for computing purposes, and that logs are preserved somewhere else for your purpose or for forensics investigation, whatever it needs. Okay, great. So there's a lot of questions. I know I skipped two questions. It's in my back of my mind. Um, and those questions were related to Logic Apps, but I hope I haven't skipped any question related to containers, right? Um, and thanks for asking those questions. There was new set of discussions that were initiated. For example, the question from Manikanta about application logs, where I then spoke about um, Splunk and Universal Forwarder Agent. So yeah, so your question brings up new discussions and adds value to this webinar. Great. So what do we have now? The thing that you have been waiting for, isn't it? Demo time, managing containers with Docker. So what I'm gonna do now is just quickly spin up the command prompt. Da, da, da. Okay, so here's my command prompt. I doubt you'll be able to see it because I haven't shared it. So what I'm gonna do is quickly uh, close it and share my screen. Stop sharing and start sharing. There you go. So I have the command prompt here. Please let me know when you see the command prompt because sometimes it takes a while to show it up. But hopefully you can see it. Okay, great. Thanks, Sujit. So I've got this command prompt running up, spinning up on my machine. So where do we go from here? In order to create containers, as discussed earlier, we'll need some kind of tool that will help you build containers, right? And that tool is called Docker. Well, is Docker the only one? Well, no, there are several other tools. Yeah, there's several other tools that will let you build containers. Kubernetes is another one. We'll talk about that in a minute. But what I've done to save time is installed Docker already. Yeah, so it's there. So if I go on my computer and type, where is it? Okay, just type Docker. So I've got various variables and various syntaxes that it can accept. So where can you get the Docker from? Where can you get this Docker executable from? Well, just go ahead and Google for Docker. Uh, okay, so, mm, so just bring in my browser. Hopefully you can see the browser. And then if you just type what? Docker for Windows. So similarly for Linux as well, you can Google for Docker for Linux or Docker for Mac operating system. So if you're using Mac, it's going to tell you how to install it, the step-by-step part of it. So you just have to follow this procedure and then install Docker Desktop. I thought there is no point showing you how to install because I know if you're attending this seminar, you have been there in IT for some time, you know how to install something on your computer, right? Just download from Docker Hub. It's going to download an executable, just say next, 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 and finish, and it's over, right? Okay, So once you have it, the first thing to do is to test if your Docker is functioning properly or not. So you just have to type docker hyphen hyphen version. Let's see what version I have. I may have an older version because it's been a month, over a month since I updated this. So say docker hyphen hyphen version 1703. I think the latest version is 19. Right, the latest version is 19, and I have a 17 version, but that is not a showstopper or a roadblocker for us. Not at all. Okay, so Docker is something that will help you run what? Containers. Will help you build containers. Docker comes in two versions, okay? Docker comes in two versions. There's a community version and an enterprise version. So if you are introducing Docker in your company, you will run all the proof of concepts with the community version. And then when it goes on production or before it goes into production, it will then or must be enterprise edition because you get a lot of community support from various people. Okay. All right. For now, you can go with community edition just to play around things. It's available for Mac, it's available for Windows, Linux, and also for AWS and Azure. Right now, I'm showing you how to build container images using your local machine on your local laptop. Okay. You can do it on any platform, AWS, Azure. We'll go ahead and do it on Azure in some time, but let's start slow. We got an hour now, so yeah, I'll just copy and paste this URL in the chat, so just in case it will be helpful for you. Uh, all right. Okay, it's an interesting question made from Sumit. Unfortunately, not. It's not available for Docker on Home Edition. No. So if you look at the system requirements here, Windows 10 64-bit, it should be Pro or Enterprise or Education. If you're using a Home Edition, it's not available for that. However, I have a solution or a workaround for you, Sumit, or other people who have a Windows 10 Home Edition. If you have an Azure subscription or if you have an AWS subscription, please go ahead and create a virtual machine there, right? A small virtual machine, 1 gig CPU, 1 gig RAM. That's fair, that's enough. And then install Docker Desktop on it. That solves the problem, isn't it? Okay, that being said, we first check the version. All right, then I need to create an image. I'll be using several terminologies during this lab called maybe Docker run, Docker pull, but I will explain what those terminologies mean. The first thing that I used, the first terminology that I used was an image. What is an image? An image is something that has your application and its runtime variables that it needs. A container image is a software package. An image is everything that is needed for an application to run. Okay, so if you want to get a small HTML file, right, http colon slash slash mywebsite.com, if that's something that you want to run, it could be hosted on a container, but behind the scenes, it will need several variables. Those variables, those software packages, it's all there inside the container image. It's runtime, it's application, it's libraries, it's all going to be there inside that image. Okay. Now, just to give you another example, I'll go to, let's say, hub.docker.com. Okay. I'm already logged in here. And then if you just, let's say you want to get a image for, let's say, Nginx. If I scroll down here, there are several repositories and lots of repositories here. So let's say you want to run a Postgres database inside a container or a MySQL database inside a container. HTTPD. So if you want to run a HTTPD application inside a container, right? You can do that. But before that, you need to pull that image. There's a sample image called as whale say. What I'm going to do is just go and search for whale say and see what I get. All right, so there's something that I get here. So when I run this Docker image, I'm going to get something on the screen, a whale saying boo, right? You can type anything here. You can say, hello, it's a great world. And you will see on the screen that whale is saying, hello, it's a great world. Okay. So let's go ahead and do that. It's just a first time practice for the first timers, just to get a idea. So you start getting the taste of containers, right? You're not building a full blown enterprise scale application here. Before you do that, you need to get a taste of it, right? How do you pull the Docker image from this repository? See, I use another term here, pull. Docker pull is another command right here. So the first terminology, first jargon that I used was image. The second one is pull. Okay. So I'm going to just copy this and go to my command prompt and say Docker and I could have just pasted that and hit enter. It's doing something, and that something is pulling. Okay, Docker pull, da da da. It is trying to pull the latest, and I got an error. Good to start with an error, right? On 192.168.165, no such host found. Copy the whole thing. All right, so let's see if I have any images. Docker hyphen ps, Docker ps, Docker ps hyphen e. Okay, so I already have that image here. Give me 1 minute. Give me 1 minute, okay? Ignore what I'm doing because I will explain this in a moment, right? Okay. Another minute, please. Okay. There's some old stuff running on my computer which is creating a conflict. So I'm just cleaning it up. Just a minute. Apologies for this. Okay, that's gone. Okay, that's done. So Docker PS, nothing. PS-A, nothing. Docker images, nothing. Okay, sorry. Just ignore what I did on the screen. I will explain it for sure as we go through this lesson, what these various commands are, what I was doing here. So we'll sort it out for sure. Okay. So what was it doing? I was pulling an image from here, right? So now let's try to run this command and see what happens. Still an error. Error response from daemon. No such host. Is it a problem with my VPN? Yep, so it was a problem with my VPN connectivity. So that's sorted. So I'm pulling the Docker from where? From hub.docker.com. What is hub.docker.com? Hub.docker.com is the most common repository that is used by several developers. Are there any other repositories around the world? Of course there are. There is a Microsoft repository as well. We call them as Azure repositories. There's a AWS repository, but most of the developers use hub.docker.com unless they are enforced to use um, Azure repositories or AWS repositories for the purposes of compliance and internal regulations. Okay, for now I'm using a Docker repository to pull an image from there. That image name is whale say. Right now the size of the image is 65 MB. It's still downloading. Once it is done, it will be there on my computer. So next time I try to run Docker pull, it will not do this again. It will not do this again because it's already there on my computer, right? So there are two terminologies that you are aware of now. One is an image, and other is a pull. There's a question on the screen which says, "Is image and snapshot the same?" No, we do not use these two terminologies interchangeably. Snapshot is a point in time recovery model. So if you would like to restore the data from a previous snapshot, that's what you use the snapshot word for. You do not use image for image in as a replacement for snapshot. So no, an image is not a snapshot, Vishwanath. So I have the Docker pull command executed, it's done, and that image is now inside my computer. How do you see whether the images is there or not? You just say Docker space images, and now you're able to see the Docker image. It's right there on my computer. So what do I do next? Well, now I run the Docker run command. Okay, it's all self-explanatory here. You do not have to memorize this, but you just need to know what the run command does and what the pull command does. Right now that the Docker image is there on my computer, I want to execute this. That execution is done with the help of Docker run. Okay, so I'll just say Docker run, and then what image do you want to run, which is Docker whale say, and I'll just copy the whole thing for the purposes of simplicity and paste here. Okay, hit enter. There you go. So there's this whale saying boo. So we can just go ahead and change this as well. Okay, so I'll say uh, let's say it's a great day. Does it do that? There you go. It says just that. So this is an application, right? This is an application, or I'll say this is an image that is executing what I want to say depending on what you are typing on the screen here. Okay. So far we spoke about images and running the image, but where is the container? That's what you may be thinking. Where is the container? And based on our previous conversation, we said that containers are ephemeral. That means they live and die. And that means that based on this discussion, the container should not exist on my computer, right? So if I say docker ps, hit enter, I don't see any containers. So docker ps is a command that will show you all the containers that are running at this point, but it's not running because the job is done and it killed itself. Oh, so am I saying that the container got killed itself, so it was running at some point in time? Yes, it was running at some point in time. Okay, so can we see all the dead containers? Well, yes, you can see all the dead containers. We'll just say docker ps hyphen a. Okay, so hyphen a is the attribute where you'll be able to see all the dead containers, terminated containers, rather say, right? So there was one container running, the first one, right? Yeah, there's the first container and second container, and then you are able to see. So when did it exit? So you're able to see different kinds of statuses here. As the container ID, it's a random alphanumeric string that is generated, the image from which the Docker image was pulled, and what command was executed, when was it created, when did it exit, and there's some random name again. These names are not given by us, they are randomly generated whenever we create a container. Okay, so we now know about what an image is. We saw Docker images command. We ran the Docker pull command to pull an image from a repository. Docker images to see all the images that we have inside the computer. Docker run to execute it. Let's do something else, okay? So let's actually host a web application. We'll we'll get a web application from somewhere and start hosting that, right? Um, so let's host a Nginx application. So I'm gonna just go, okay, this Nginx right here, or an HTTPD, anything is fine. So both of these are web application servers. Just go to Nginx, okay, and what kind of binaries you want, you can select that. And there's a step-by-step description of this, okay? So I'll say Docker pull Nginx. So when I copy this and paste it here, Docker pull Nginx, and hit enter, what is it doing? It's going to the internet, right? Specifically to hub.docker.com and getting that image for me. And this is only just for the first time. Later on, that image is stored inside my computer as long as I keep it. So I can remove it as well. I'll show you how to remove it. You might have noticed me removing few things earlier when I was stuck, but I'll show that to you and explain it again. The question from Vishwanath is that can we see what's there inside the image? Yes, you can see, and it's there inside the documentation. So what is the image doing? You should be able to find that out inside the documentation. So there's a detailed step-by-step documentation here. How do you modify the content inside it? How do you modify that file? So you need to use a YAML file to modify that. We'll do that in a minute, step by step. Yeah. Okay, so what's my CLI doing? All right, that's done. There's another question from Krishna. So running an image will automatically create a container at the backend. You don't create a container specifically. You are right. You do not create a container. Um, when you run it, when you're running it, You're saying that here run the application. When you're running the application, it just means that it needs a container to run the application. So it does not need an explicit command to create the container because it understands that you want to run the application. So it needs to create a container to run the application. All right. So what do we do next? Docker pull nginx. Now this is a web application. How do you host it like a web server? How do you do Docker run? There you go. It's right here. Docker run hyphen hyphen name, and there's some kind of a content inside this. So what is this doing? This guy here has just created nginx. What is nginx? For those people who have not heard of nginx, nginx is a pretty sophisticated modern way of building web applications. So nginx has a lot of things. It's a reverse proxy, it's a load balancer, it's a mail proxy, it's an HTTP cache. So pretty much today's internet facing web applications are built on nginx, right? So a lot of these web applications are going through that. So we got this nginx image, but do we have any web content inside it, right? So let's say you want to make some kind of your own web application. How do you do that? We have the nginx. Good. Nginx is the base. Nginx has the variables, but where is the content? Where is the content? Like your HTML page, etc. So what I have for demonstration purposes, specifically for this lab, is let's see what I have. Go here. Mm, where that is. Okay. So I've got some kind of a web content here. Okay. And I've also created a Docker file. There's a dockerfile.txt, which is right here. And I'm saying that using this image, okay, from nginx colon alpine, using this image, do something. Copy, okay, copy the content which is in this directory, and dot means this directory, okay, C, delta, whatever my folder is. Copy the content inside this directory to that Linux folder. That Linux folder is /user share nginx html. Okay, so what am I doing? I'm copying whatever is there inside my directory into this folder inside this image. Now I'm customizing it. Now I'm modifying this container file. Okay, so this is a small web application that I did not make it. Somebody made it for me for demonstration. So I just opened it. So it looks like that. C colon / delta index.html. It's a small static web page. Okay. All right. Few cricketers. There's the parliament. There's people clapping. There's the currency. It's all there. So I want to host this as a web application inside that container. So what am I going to do? I have to run few commands. Okay. Uh, I hope this part is not confusing for you. Yeah. Okay. So so let's go ahead and do it. Docker. What do I want to do? I want to build a new image. Okay. I want to build a new image using the file. Oh, I should first navigate to this path, right? Because this is where the file is. CD. Okay. I must first navigate to that path and then run docker build. Look at that. Now there's another command that you're getting introduced to, or a technical terminology or a jargon. First one was what is an image? Second is docker pull. Third is docker run. Now it's docker build. Okay. You're building an image with what? With a file which is located inside the same directory, and the name of the file is dockerfile.txt. Okay, and I want to tag it. Let's say I want to tag it with, let's say, name alpha. Just put some name there and hit enter. Invalid argument. What's the fun without an error message, right? Okay, lowercase alpha. Docker build requires exactly one argument, which is a dot. Okay, Every error message teaches us something, okay? And the first error message taught us that it must be in lowercase, right here. The second error message tells me that, okay, you want to create a image, okay, good, with this file, okay, good. The tag is alpha, but where do you want to create it? Okay, so this dot is very important. So if I put dot there, it means that I want to create it in the same path. The entire content is there inside the same path. That's what it means. Okay, so give it some time and it will build the image for me. In the first example, the whale say example, we we chose to, wherever it is here, we chose to create an image, we chose to create a container from an image which is hosted on hub.docker.com, right? Which is there. If you would like to customize it, modify it, well, you can do it. But here in this case, what I'm doing is my entire web content that is there. Let's say you got a complex code and all, right? And now you want to make your own image out of this. Well, you are doing that, but with the help of a Docker file. You're not reliant on hub.docker.com. Okay, although it is picking up nginx alpine from hub.docker.com, but when it is pulling from there, it is also injecting the content of my HTML inside that path, inside this path here. Okay, so let's go back to the CLI to see what's happening. It's still stuck there. Okay, so no questions were there in the chat. We see something on the screen. It's pulling it from the internet. Small package, 2 MB. All right, so we got something. Whatever, we don't care. So I'll just say Docker images. Oops, what happened? Docker images. So we have Docker Whale say an Nginx as well that we deployed, and there's an alpha as well here, right? Alpha colon latest. That was the name of the image, isn't it? If you go back, scroll up, see, this is what we want to create here. The name of the image is alpha. Now what do you do? Can somebody tell me what do you do now? You have an image. After you get the image, what do you do? It's not a poll, it's just a question. So once you have the image, what do you do next? What did we do after getting the whale say from the internet? Run it. Exactly. Thank you, Krishna. Thank you, Sujit. You run it. So I'm going to run Docker and say run. Docker run what? Well, I want to run my image called as alpha, right? That's simple. But you have to tell that it's a web application. You need to tell that you need to run on a particular port. Internal port is certain number, external port is certain number, right? So you need to tell and put that in the form of a variable, right? So it will be -d and then -p for port numbers. Internal port number 80, external port number is also listing on 80, and my image name is alpha. Let's hit enter to see what happens. There you go. So it's running. Always end up typing typos there. Docker, and now if I type Docker PS, look at that. This image is still running. Yeah, it's running on port number 8080. Good. So what will happen if I launch the browser and type http://localhost? Will I see my web application? Let's see. So localhost, hit enter. There you go. Right? It's right here. http://localhost on port number 80. I've got my web application running inside a container. Docker run, -d for daemon, -p, port number, and then which image. That's it. It's running. Docker ps. It's running from past 53 seconds. I will go ahead and kill it. Okay, I'll go ahead and kill this um, container and then refresh this page to really prove to you that it is running on a container and not from a local C colon delta file. Okay, so what will I do is say docker and then kill it. Okay, rm for remove, and then you can either type the name objective underscore Shockley, you can type that, or put the container ID, or just put few strings. That's fine as well. Just put b3. I'm just putting first two characters or first three characters. That's fine. You cannot remove a running container. Stop the container before attempting removal. I love these error messages because it I don't have to Google. I don't have to search for them in the internet because it tells me, hey, stop it before you can kill it. Or use -f, which is -force, right? You want to kill it anyway. So I can either do this -f to forcefully kill it, or gracefully kill it by first stopping it. All right, that's gone. And now it will not be available inside Docker PS. Let's say Docker rm b3d. Now it is stopped. So if I do Docker PS, I can't see it. But if I do Docker PS -a, I'm able to see, oh, it's not even available because we stopped it, yeah? Because we stopped it and removed it as well. We removed it, mate. Aha. We not even killed it, but we not only killed it, but also removed it. So now I'll go back to this and refresh it. This should not work because we killed it, yeah? It's not available. Excuse it. It's in German, but it just says that this is not available, right? So that's how it is. I hope this concept of containers is clear. So two things that we did. Number one is getting a image from hub.docker.com, running it as a container as is without any customizations. Second, we created our image using our customized files. Let's say the web developer gave you all these files. You use them to create your own container and then running that container on your local machine. Can you run? The question from Krishna is, can you run two images of the same type? You'll create two containers of the same type. You'll not create two images. You will create one image, right? You'll create one image, and then you'll create containers, multiple containers from that image, and then load balance it. Right, Krishna? Does that make sense? You'll create containers from that image. And yes, you can do that, but with Kubernetes. And that's the next section. But we'll do that. So these kind of advanced things are done with the help of an orchestration service. And that's where we need orchestrators. Okay, that's where we need orchestrators. That's very important to talk about. So hopefully you've understood what containers are. Just to give you a summary, a gist of it, now you will be able to relate to these dots. Container images are nothing but software packages. They are pieces of code. They have a runtime application. They're all sitting together to build that web application or anything you want for you. Okay. You build containers with Docker. We learned about Docker image command, Docker PS, Docker RM, Docker RMI as well. Let me show that to you. Go back. What do you see on the screen? Do you see um, the CLI or do you see the PPT? Where's my chat? I don't know. Stop sharing and start sharing again for a better view. Okay, we've got the CLI here. So few commands that I missed to tell you was Docker images. It shows you all the images, but if you want to remove it, right, you type RMI. So to remove a container, you're typing RM, but to remove a image, you'll type RMI. Okay, so if you type Docker RMI and type alpha, I'm deleting my image. Okay, that's gone. So if I do Docker images, it's not there. Okay, so there's a question from Sujit. If you want to open this website from another PC, any other configuration is required? No. If I have a, I'll just do ipconfig and give the IP address to you. If you're sitting locally on my LAN, otherwise you have to publish with the public IP. So there's a question from Manikanta. Say I have an app is running in a container. How is the new version of an app deployment done? A new image is built with the new version of the app, or already running containers are updated with the latest version. So these are called as more technically called as blue-green deployments, Manikanta. So you will have multiple versions of it. You do not update the same image. You will be creating a new image and using that image to build new containers on a new app. These are called as blue-green deployments. So one deployment is production, another production is test environment. So multiple environments. You do not update the test with prod, but you will have um, multiple environments running in parallel. A prod environment, a test environment, a QA environment. All of them they have their own URLs and set of testings to do. So to answer your question in one word, it's a new image. Okay. All right, so hopefully this has been informative to you so far. We have to move on. Thank you, Manikanta. We have to move on to the next part, which is the need for orchestrators, I believe. I have to share the presentation. Stop sharing my CLI and share this. Okay. Hopefully you should now be able to see the need for orchestrators. Yep. Okay. Great. Sorry. So you might have already noticed that how dramatically things have changed in the way we are hosting, building web applications and maintaining them as well. Containers have dramatically changed everything, right? So these are managed by Dockers, as you know, but scalability is still a big challenge with containers. One question that was brought up here was about, I think by Sujit, he was asking, can I have containers behind a load balancer? Well, that's something, not a complex thing. It's something people want, organizations want. Load balancer is something that's really required for availability purposes, and there's a lot of automation that's required. So these orchestrators like Kubernetes, Mesos, DCOS swarm, Docker swarms, these assist in orchestrating a lot of things. The life cycle of a container, which is provisioning, deployment of containers, redundancy and availability of containers, scaling them, moving containers from one machine to another. Right now, I've got containers sitting on my machine, but what if my container, my laptop is going bad? It needs to be moved. The container needs to be moved to another machine, right? So let's say my CPU is going bad or my hard disk is getting filled up. I need to move my containers to another machine. There are certain situations where I need to expose my application to the outside world, to the internet world, load balance them, monitor them, do some kind of health monitoring. The very basic thing that we did with Dockers is the just hosting a web application in a Docker container. But the things that I just listed, like automation, scaling, movement from one host to another, load balancing, health configuration, all of these needs to be done with the help of orchestrator. So you use an orchestration tool called as Kubernetes or Docker Swarm, and depending on the kind of tool you may be using, it has its own commands and syntaxes. Kubernetes is the gold standard, right? Kubernetes is now the gold standard these days to orchestrate your web applications. It's very important. It has gained a lot of popularity with DevOps practitioners because we need to deliver the web applications quickly and also have orchestration done at the web application level. Next couple of minutes, let's understand uh, the Kubernetes architecture. Okay, so we have uh, the various components of AKS cluster. Okay, so you got Kubernetes control plane, which is a box on the left hand side, and then a box on the right hand side, which is Kubernetes nodes. These are the various components which communicate with each other to orchestrate the functioning of a container. So you got worker nodes. These are called as nodes on the right hand side. They are also called as worker nodes, which are, let's say, 3 virtual machines in this case. That is where your containerized applications are running, right? On the right hand side, you see those 3 machines. On top of those machines, your containers are running. These 3 machines altogether work as one single worker node. They are in a cluster. On the left hand side is a master node, or also called as a control plane. The worker nodes communicate with the master node to do several activities. Let's start with the first component, which is the Kube API server. You see this middle box, Kube API server, right here. If you see my mouse, I'm pointing it there, the Kube API server. So this Kube API server is a component of Kubernetes control plane, which will expose your entire Kubernetes API to the front end and the back end. It talks to several components like Kube Scheduler, etc, Control Manager, and there are several control managers inside it. So what is etc doing? What is etcd doing? When containers are provisioned, they are um, created and killed as well. And to maintain that log, to maintain that history, you need to always have how many containers were created, what their names are, what is their ID, when did they exit, when did they create. All of that is maintained inside the etcd. So etcd is your single point of truth for all your container related data. It's like a key value pair. It's like your database. It's like a NoSQL database. It's just all that information. And then there is Kube Scheduler. So Kube Scheduler will let you schedule the pods. Now I'm introducing a new word, pod. So when we talk about containers, right? Containers as far as Kubernetes is concerned, we will have um, first thing is your virtual machine. The second thing inside the virtual machine is a pod. Inside the pod, there is a container, right? So the containers are not directly sitting on that virtual machine. Containers are sitting inside the pod, and containers have a 1:1 ratio. That means one container, one pod. You may be asking, can I have multiple containers inside the pod? Technically, yes. In production, you don't do that. So what is Kube Scheduler doing? Kube Scheduler is creating new pods as and when required. When the containers get killed, the pods are killed. When the containers are required to be provisioned, they get provisioned as well. And it is a Kube Scheduler which factors all of these requirements and decides when these containers should be created. There could be several factors. It could be hardware related factor. It could be software related factor. policy constraints that you have within the environment, right? So you will have a kube scheduler doing that kind of activity on those virtual machines. So kube scheduler is doing what? It is provisioning containers inside the pod. Okay. What is etcd doing? The etcd is maintaining how many containers are created. It's more like an excel sheet. You can think of an excel sheet. What is a container name, id, when did it exit, when did it get created, etc. Let's talk about the controller manager. It's two times right there. That means it's important, right? Anything that is stressed multiple times is important. So you got cube controller manager and there is a cloud controller manager. So what is a cube controller manager? It is a part of the master node. A master node is also called as a control plane. So how will you ensure that the containers are replicated to multiple nodes? How will you ensure that? So if a container is created on node 1, which is the virtual machine 1, how does it get replicated to other virtual machines? So the cube control manager is responsible for that purpose. So there is a replication controller inside the kube control manager that is responsible for maintaining the correct number of pods in every Kubernetes node. It also has an endpoint controller which is responsible to expose your application out to the internet, right? So that's what kube control manager does. Then there is a cloud controller manager. This one determines and checks the cloud provider. Let's say your AKS is hosted on Azure or your Kubernetes service is hosted on AWS. Regardless of where it is hosted, you will still have a check done to see if a node has been deleted in the cloud after it stops responding. So let's say somebody deleted this particular virtual machine, this little box or this box, or it got terminated for some reason, right? So the node controller, which is there running inside the cloud controller manager, it ensures that there are right number of nodes hosting your pods and indirectly hosting the containers. This cloud controller manager is also responsible for routing the internal underlying cloud infrastructure components. And when you talk about exposing your web APIs, web application to the nodes, to the load balancer, to the internet, it is the cloud control manager that does that. If you look at the picture, the cloud controller manager is directly connected to the ISP, to the internet, to the cloud. So this guy is, or this component is really vital to expose your web application to the internet. Okay, so the cloud controller manager is doing its own bit to make sure that the nodes are up and running. Nodes are the virtual machines, the Kubernetes nodes are up and running, and also that the service controller is creating, updating, and deleting the load balancers as and when required. Okay, so this was about the master node, also called as the control plane components. Then there is the Kubernetes node on the right hand side. You got the kubelet. Kubelet is an agent. It's just like an executable. It's an agent that is running on every node inside the cluster. So it makes sure that the containers are running the pod. We just said that the virtual machine is running the pod is running the container. It is a kubelet which makes sure that the health of the pod is it's good, right? It makes sure that the containers are running inside the pod. What is a kube proxy? There's a kube proxy. A kube proxy is a networking concept. How would these containers talk to each other? How will they form an interconnectivity between each other? So let's say you got a pod So I'm going to call these machines, give them names, okay? So I'm now focusing on the Kubernetes node box. So I've got machine A, machine B, and machine C. On each of these machines, you got container A, container B, and container C. How will these three talk to each other? They will talk to each other because of the networking component that is created with the help of kubeproxy. That's what does it. Okay. So container A, B, and C talk to each other with the help of kubeproxy. The kubeproxy maintains those network rules. So let's say the container A is a web application. Container B is a database, right? We need to have some kind of a communication with each other, database and the front end. So it's a kubeproxy which talks and maintains that packet filtering layer, forwards the traffic back and forth between the containers. Okay. Then there is container runtime, which we cannot see in the picture, is the container runtime which is responsible to give you various environment variables that are responsible for the containers to run. There are several other components, like there is DNS for name resolution, something that gives you a web UI dashboard for the Kubernetes clusters, monitoring component, cluster level logging. All those logs are maintained separately using Kubernetes cluster. So Kubernetes is an orchestration service that will let you provide availability of your containers. The logs are kept separately for the containers because Kubernetes knows that containers are ephemeral, they will live and die as and when required. The DNS services are all maintained by Kubernetes. Providing networking component between the containers is all provided by AKS. Earlier, when we created containers using Docker, right, we just created containers like that. There was no way I could have interconnectivity between them. There's no way I could have interconnectivity between them. So if I want to have some kind of an interconnectivity, expose them to the internet, maintain them, manage them, and provide a modern enterprise grade web application, I need some kind of an orchestration service, which is a Kubernetes service. Okay, so I hope this is clear. The future is bright. The future is bright with AKS. Okay, containers are quickly eating up the space of the older methods of hosting web applications. It is a new modern method, and the momentum is gaining towards containers and more towards AKS clusters. So AKS is the future of infrastructure, and it's not going to slow down anytime soon. So you need to have a deep expertise in orchestrating with AKS, and uh, yeah, there are several providers that are providing AKS services. You talk about Amazon or Azure, or of course Google Cloud. AKS is a brainchild of Google Cloud, and later on it was then handed over to an open source foundation called as CNCF, Cloud Native Cloud Foundation. It was then given to them and made it as open source. As always, Google does great things. So AKS is not AKS, but Kubernetes is one of their brainchilds, which was then adopted by other providers, starting AWS first and then Azure. So the landscape of web hosting is constantly changing here, right? Okay, so I'm going to switch back to the Q&A panel for a bit, and then we will go to Azure console to see if there are any questions. Um, da, 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 da. How can I delete multiple images? You mean in one go from your computer? Question is asked by Saranya. Okay, you mean one go like this from here, from this console? Just write a for loop. Just write a for loop um, for each in remove docker rmi alpha. You need to write a for loop for that. Okay, so for syntax is incorrect, so you need to use the right set of variables. You need to write a for loop to. It's not something more specific to Docker. It's more of a Windows thing. But if you know PowerShell, you will use for each. You can use Python for loops. Okay. So what am I going to do now? I will launch my Azure portal. Okay. Navigating to portal.azure.com. Okay. One moment, please. Please. I'm just logging into my Azure portal. Hopefully, you can see my screen. All right. So one thing that I want to tell you, I'm sure you might have had your own plans for the day, but somehow we had a lot of questions, and I felt that it's important to address your questions. I don't want to have any questions lingering in your mind during the class and after the class as well. So that's why I stressed on Q&A. Although we had limited time, but we respect your questions, and because of that, there is a repercussion here, which means that we have to extend the class in order to um, complete the demonstrations. I really appreciate your patience and time. Um, Apologies that we had to extend um, by maybe another 15 minutes. We should be done. Uh, Thank you so much for your patience. So that being said, I am right now in my Azure portal, isn't it? So let's go ahead and spin up few containers inside the Kubernetes, inside the pods, and see how that goes. Okay. Um, So I will have the Q&A on another section. So parallelly, I can answer any questions you have. All right. Just a moment, please. Okay. So let's go ahead and spin up our container here. I'll go ahead and type Kubernetes services here. Okay. And then type add. So if Azure portal is new to you, okay, I'm just cruising through this, uh, assuming that you know the Azure portal. So on the left hand side, you will see all the Azure services, right? On the top right hand side, you see your name that you're logged in with. And then you have the dashboard. You see all the services that you're spinning up already. And if you want to create a new service, you can just go to create a service and type Kubernetes here because I want to create a Kubernetes service. So I'm just doing that. Okay. So click on that and click on create. All right, so everything goes inside a resource group. So I'll create a new resource group called as, let's say, AKS. But in production environments, you'll always follow your naming standards and naming conventions, okay? Kubernetes cluster name, just put that as well. Region, I really don't care at this time. Leave it as US Central. What version of Kubernetes do you want to host? I'll choose 1.16. The minimum node count is 3, okay? If you recall the picture that we had, diagram picture, um, there we had a master node and Kubernetes worker node. So here we're talking about 3 nodes inside the worker nodes, okay, and each one of them is DSV2 in size. What is DSV2? Well, DSV2 is 2 CPUs and 7 gigs of memory. Okay, you can change it, right? Depending on your production requirements, you can change it to, there's several permutation combinations here, but since this is just a lab, I'll leave it like that. And okay, as far as networking is concerned, you can have uh, as many pools as you like. At this time, I have just one pool. I can have a virtual node. I'm just disabling virtual node. What is a virtual node? So let's say there is a lot of load uh, getting into my nodes and you would like to burst it from 3 nodes to 4 nodes, you need to enable that. So mostly this is a scaling part of it. At this point, I'll disable it and click next. Authentication. Do you want to integrate that with Azure Active Directory or something? In that case, you will have the authentication done. Encryption. Do you want to have the OS disks encrypted? Um, you have two options here. One is if you would like to encrypt at rest with a platform managed key. In this case, the keys will be with Microsoft. But if your regulation says that I don't want to keep the keys with Microsoft, I want to keep my own keys, then you can put that key in your key vault, right? There's another service called as Key Vault, and you can put the key there and encrypt using that. I don't want to do it at this time, so I'll let Microsoft manage it and then use networking. So you got two options here as far as networking is concerned. Basic is where Microsoft manages the entire networking part, and advanced is where you manage the networking part. You can assign the IP address ranges. These are called as the CIDR blocks, the classless interdomain routing. You can assign these IP addresses or CIDR blocks to your containers using the advanced routing, put them in your own virtual network, etc. Right? Or use the basic method. I'll use the basic one. We really don't care about the networking because the focus is on Kubernetes clusters, right? Integrations. Now, I know someone who was asking about um, logs. Where do you keep the logs? Well, here, see the seamless integration with log space analytics. So there's a new, not a new service. Earlier it was called as Operations Management Suite. Now it is called as Log Analytics. So you will have all the logs getting into the Log Analytics workspace, right? So you do not have to even put that agent, the Splunk agent example that I was giving, right? And finally the tags, and then review and create. You have to just give it a minute before it gets created. All right, finally you click on create. All right, it will take a minute to um, create that for us, but in the meantime, I'm gonna show you a web application from where we're gonna deploy a Kubernetes container or a container inside the Kubernetes cluster, right? So I have to search for that. It's inside the Azure, what's it called now? Container Kubernetes uh, lab or tutorial. Let's see. It's called as, there you go. So inside this Kubernetes cluster, I'm deploying this app called as a voting app. Okay. And for us to have this voting app, I need to get this YAML file. There you go. This is the YAML file. So I'm just going to copy this, the whole thing from top to bottom. Or I can just use this copy command. That's much simpler. Copy it and then host it as a YAML file inside my container, right? So this is the URL that I'm using. I'll put it in the chat so you can do your own lab as well. And these are good things to start with. Initially, you don't want to start building complex applications, but these are good to give you a taste of how containers looks like, how Kubernetes looks like, so that you can play around various commands you have inside Kubernetes, which I'm going to show in some time. All right, so I copied it. And how do I paste it here? Well, there's something called as Azure CLI, and I will expand this. Okay, I'll just wait for it to settle down. So there are two things that we're waiting for. One is the Kubernetes cluster provisioning, and second thing is the terminal. because I have to copy inside that file. Okay, so da, 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 da. So I will create a new file here called as vi. So if you're not comfortable with Linux, don't worry. It's pretty simple. I'm just saying vi. Vi is like opening Notepad on your computer, right? So I'll just say new app one.yaml. Just typing that, and it opens up a empty file. There's nothing inside it. So I will insert the content, this content that I copied from here inside this file. Paste it. All right, it's right there. And I will save it. Write and quit. WQ is write and quit. Hit enter. And if I want to just look at this file, say new app1.yaml. Okay. Right, the whole content is right here. What is this file? What is there inside this file? What is it actually doing? Well, it is publishing a web application with the name Azure Web Apps into my containers. So the image is a Linux container, which is hosted in kubernetes.io. It is not hub.docker.com. It is kubernetes.io using a Linux image and using certain memory specifications. It's right there. The port number that it's using is 6379 is the backend port. And it's also using a load balancer right here. That load balancer is exposed on port number 80. Okay. So these are the things that are configured inside this YAML file. There's some background noise. I suggest that you keep yourself on mute. Thank you. So going back to this, I have this file, and in parallel, my deployment is also complete. It says your deployment is complete. So I will type, let's say, Kubernetes services, and looks like it is actually complete. Good. I'll make some space for myself and go here. So what do I do now? I have to go ahead and deploy this web application to my Kubernetes cluster, isn't it? So how do I do that? I will clear the screen here because you know that I need some space. The first thing that I have to do is using kubectl command, just query my cluster. I'll say kubectl get nodes. Hit enter. It says it is unable to connect to the server. Whatever. The reason it's not able to connect to the server is because there may be several clusters. I have just one cluster, but there may be several hundred clusters in production environments. Which cluster do you want to connect to? And you want to get nodes from which cluster? So you have to first connect. Just say AZ, AKS, you need to say get hyphen credential, and then the resource group, hyphen G's resource group is AKS. So I'm telling that my cluster is inside a resource group called as AKS, right? That's my resource group right here. And the name of my cluster is what? The name of my cluster is web app. So I'm specifying certain things here. Okay, so there's an error. Errors are good. Get hyphen credential is not in AZ AKS. AZ AKS get hyphen credential. Maybe I'm typing a typo here, so I'll quickly see if there is a. Okay, it's credentials. It's a plural. Okay, it's a plural. I just missed an S here. Okay. Okay, now it says that any queries that I'm going to do, again, request to put on mute, please. Anybody who's not on mute, please on mute, please. Thank you. I'm sure it's not my kids. My kids are sleeping. So, what do we have? Da, 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 da. All right, so what I'm saying here is that next time when I'm going to run any command, it's going to connect to this AKS cluster inside this resource group. Okay, hit enter. Let's see what we get now. All right, we got these three nodes. If you recall from the previous lab here, when we were creating the nodes, we mentioned that I need three nodes, and that's the minimum number of nodes that you got to go with. See, these three nodes, and their names are mentioned here, AKS-agent pool. Okay, so now everything is manageable using the GUI. You can manage everything right from this console, but CLI is always more powerful than GUI, and that's why I always prefer using command lines like these. So now we have our file ready, right? Our file name, I don't know what was the file name. Our file name was new hyphen app or something, right? This one, new app hyphen YAML, new app1.yaml. Yep, it was new app1.yaml. So looking at the history, yeah, it was new app1.yaml. So now I'm going to use this app1.yaml to push it to the Kubernetes cluster. So I'm again use the kubectl command and say apply the file, which is -f. The file name is what? New app1.yaml, and hit enter. And that's it. Wait and watch. Okay. So what it did is it created containers inside my Kubernetes cluster inside the nodes. Now it's time you can um, expose it to the internet just by saying kubectl and then say get service Azure vote front watch. Okay, the kubectl is not recognized, so I've got fat fingers. I need to remove that T. There's a typo. Okay, so it has a public IP right here, right? So I'm going to copy this and paste it there. Hit enter. So you have the Azure voting app on the public IP. This is a sample web application that got pushed to Azure App Services here inside the Kubernetes cluster. So this voting app, even you can try it. You can just go ahead and uh, paste it. Yeah. So I have put that in the chat for you to try. It's publicly available. Okay. So just play around these numbers and it's going to go inside the sample database that's there. Reset that. So I hope you got an idea of containers, an idea about orchestrating those containers with the help of um, Kubernetes cluster. Well, there's a lot more things inside that. Here you can go to metrics and identify how many hits are getting into it per second. You can go and look in the insights to know more about your web application, the kind of traffic that's getting into your web app. See, node CPU utilization. There's a lot of performance metrics that can be gauged right from here. Now, I'm going to open this to everybody if you have any questions. But first, I will take the two questions that were left out as far as logic apps is concerned. And really thankful for your patience and still waiting for me to answer. I'm scrolling up on the questions and answer sheet to see where that question is. Okay. Okay. Can you please explain logic apps in more detail? That was one question. And is container runtime is hosted on containers or virtual machines? I think I answered that question, but I don't know, there was something that I missed. Unfortunately, I don't see that question now. Yeah, please, that will be really helpful. Okay, so here's the question. How are logic apps helpful in terms of managing events? Good. Or when one is better, which one is better? Okay, I'll give you a scenario here, okay? I was working with a startup company. It was an IoT based company, right? And they had these not Raspberry Pis, but something similar. There was Node MCU chipsets, and they had these small wireless connectors to it and a camera as well. It was very small device, as small as maybe your mouse, right? It was small. So that used to take pictures, and they put those kind of devices everywhere in kindergartens, where parents could see how their kids are behaving and performing inside the kindergarten, right? So probably the parent wants to get alerted when a kid is crying or there is a distress signal, right? So that was the motive of the company. They were building those devices for certain samples and demonstration purposes. They gave away these devices and to the kindergartens and to some parents as well, right? So that's the bottom line that they want to do. But how does Azure come into picture? How does logic apps come into picture? So that device had a camera which will take pictures. That picture then gets uploaded to Azure Blobs. That picture is then scanned with the help of artificial intelligence tools to identify the baby's name and their expressions. Expressions like if the or the baby is crying or is smiling. If it is smiling, happy, we don't care. But if the baby is, let's say, crying or in signal of distress, then an alert is sent to whoever, yeah, to the guardian, let's say. Now, the logic apps is defined to look at that picture every time a picture is uploaded to the blob storage. It sends an email to the parent. The parent, if he wants to look at the picture, he will look at it. But then he's more focused on distressed picture, something that's he really wants to focus on, something he needs to look at for sure, which is maybe baby is crying or maybe got hurt or something, right? So the AI then tags that picture. So the logic apps is then looking at those tags. Every time the artificial intelligence tool tags that picture as distress, the logic apps sends a priority alert to the parent. This is an example of logic apps. You can do it with function apps as well. But function apps, you need to do the whole coding yourself. The major difference between logic apps and function apps is that with function apps, you have to do everything yourself. You have a blank slate to start with. Logic apps gives you a workflow. There are predefined templates. There are predefined APIs where you do not have to work hard in writing the code. I hope that's clear. Alvina Drago. Great. All right. So looking at some more questions on containers. So a container basically contains only the code. Yeah, I think that's addressed. All right, so I think all your questions have been addressed here. The agenda for today's 2 hour discussion has been extended to 2 hours and some extra minutes, but I hope this has been an informative, productive, demonstrative time for you. Um, you'll take this back to your environments, maybe expand your skills, extend your skills. Um, I'm still constantly monitoring the chat. If you have questions, please feel to do so. But I will now hand it over to Whizlabs for surprise that they have for you.
Hello.
Hey,
Hello, Anand. Uh,
yeah,
okay.
you are audible.
Thank
Please
you.
go ahead.
Thank you, Anand. It was quite engaging and with live demos and Q&A sessions. And I hope the attendees found it equally valuable. And apologies for a slight extension of the schedule, but I hope that was quite useful. Before we go ahead with the offer, I will just take a couple of minutes and go with some of the formalities over here. This Okay, I will make myself as a presenter. Just a couple of minutes, okay?